Hello, this is Professor White. Today we will talk about absolute value inequalities. Inequalities that have absolute values in them. Let's get started. Let's talk about meaning of absolute value. The meaning of absolute value is distance away from zero. How far away are you from zero? Let's look at this example. If you're at -5, how far away are you from zero? I am 5 steps away. Let's look at 5. How far away from zero here? I am 5 steps away. Because of that, absolute value of -5 and absolute value of 5 are both 5. Now, how do I write that in algebra? This is how I write it. Braces. Absolute value of x is -x if x is negative. What does that mean? So if this is -5, you put a -5 in front of that, it makes it a +5 and it gives you a positive answer. It's equal to positive x if x is greater or equal to 0. So positive 0 is 0, positive 1 is 1. Okay? So this is the official algebraic definition of absolute value. This is the physical definition of absolute value, and this is the mathematical examples related to absolute value. All right, now that we have absolute value in order, let's look at that. Somebody is asking me to solve absolute value of x is 5. You're going to do it this way. You're going to have two parts. I know absolute value is either -5 or +5, negative x or positive x, depending upon what x value is. Then put whatever that is next to it right here and try to solve it. So equals 5. That gives me x equals -5. And this one equals 5. That gives me x equals 5. So if I were to write this in set builder notation, I would have written braces -5, 5. All right? If they were to ask me to do it in number line notation, I would have put 0, -5, 5. I would have put a dot here and a dot here. So this is the set builder. This one is the number line. And this one, oh, wait a minute. I cannot do interval because we are not talking about interval notation. Interval notation is not applicable. I can't do it. Let's look at this. The same way. You're going to have two parts. One is negative part, put parentheses around it. One is positive part, put parentheses around it. Then write down this equal part, equal 5, equal 5, and solve. Okay, this is going to give me -3x plus 1 equals 5. Subtract 1. -3x equals 4. X equals -4/3. How about this one? +1 plus 1. 3x equals 6. X equals 2. Let's write these in two notations. Set notation. -4/3, 2. And the number line notation. -4/3 around here, 2 here. All right, very good. Now, what happens when I have absolute values on both sides? So you're going to have this situation. This one is going to be either 2x negative or 2x positive. And this one is going to be 4x plus 1 negative, or, 4x plus 1 positive. So when I couple them up, I can couple these two up. I'm going to get positive 2x equals negative 4x plus 5. I'll couple these two, negative 2x. Oh, this one is not. Okay, I'll have, let me do it in order. Negative 2x with negative. I will have negative 2x with positive. I will have 2x with negative in parentheses, or I'll have 2x and 4x plus 5. Then all of a sudden I notice something. I look at this, I have negative, negative on both sides. If I multiply both sides by negative, I get this. And these two, negative, positive, positive, negative, these two are the same. So I did not end up having four things, but I end up having 2 things. So in other words, as a shortcut, just minus plus one of them and keep the other one the same. So that will do the job, because otherwise you'll be repeating yourself. In other words, 2x equals 4x plus 5, where both of them are positive, or one of them is negative. That'll do the job. So let's solve these. So I'm going to put 5 on one side, and then 2 on this side. So I'm going to have that. So that will give me x equals negative 5/2. That's one of them. Let's move this over here, and let's move this over here. And then that will give me x equals negative 5/6. Guess what? I ended up with 2 answers there. If I went ahead and solved all 4, you would have ended up with the same 2 answers anyway, so you don't have to do it 4 times. Now let's look at a tricky one. Here's a question. When is an absolute value equal negative 2? The answer is it's never happening. So the answer is no solution. So please pay attention to this. When you see an absolute value on one side and negative on the other side, don't even get started and doing all these things. Just leave it alone. Okay. Now we're going to start doing inequalities, but it is done the same way. So the type of inequalities I'm talking about involves the less than or equal to. You're going to have 2 parts. That comes from the absolute value thing, plus x or minus x. And you're going to keep this the same. This one is that, and this one is that, the same. X is less than 3. Let's multiply both sides by negative 1. X is greater than negative 3. You put these two together with an and statement. X is less than 3 and x is greater than negative 3. What are you going to end up having? Here's less than 3, greater than negative 3. I am between here and here. Open, open. And this is typical for less than questions. You'll always have a sandwich situation. Coming from here, coming from here. Typical. I'll put in parentheses, sandwich. And that is when you have less than or equal to kind of thing. So you'll end up with a sandwich situation. All right? Let's do this example. So this is less than or equal to, so that means I'm going to have a sandwich situation here. But let's do it. I'm going to have a positive, put parentheses around it, 2x minus 5. I'm going to have a negative, put parentheses around it, 2x minus 5. And then I'm going to do this in orange. Do not change that. Do not change this. Do not change that. And then you're going to do that. You're going to do the manipulation in a second. All right, let's do this one. You're going to add positive 5, 2x less than or equal to 10, x less than or equal to 5. You divide both sides by 2. Here's 1. Let's do this one. Work the negative in. Subtract 5. Divide by negative 2. Less than or equal to 5, greater than or equal to 0. How are you going to show that? Here's 0, here's 5. It's sandwiched. Since this has an equal, that means it's going to be black dot, black dot. Now, if I want to write the same things, this may be a good moment to review the interval notation. How am I going to write this in interval notation? This one is the number line. The interval notation will say small on the left, big on the right. And since they are both black dots, I'm going to put brackets. Now let's look at the set Bindler notation. That one was with the braces. Braces, x such that. How am I going to write this? X in the middle, since it's sandwiched. 0 on the left, 5 on the right. So that covers it all. I have it on 3 notations. Let's do this example. What is different about that? Again, less than, it's a sandwich, but the leading coefficient of x is negative 2. I'm going to have 2 parts. Positive 6 minus 2x. Negative 6 minus 2x. Now, let's subtract 6. Negative 2x. Negative 2. Divide by negative 2. Uh-oh. Remember, I'm dividing by negative numbers, so that means it has to change direction. X is greater or equal to 1. Work the negative in. Add 6. Divide by 2. What did I have? Greater or equal to 1, less than or equal to 5. Number line. Zero in the middle. Here's your 1. Here's your 5. I want to be between 1 and 5. Black dots because I have equal 1 to 5. Interval. Small number on the left, big number on the right with the comma. Since they are black dots, bracket, bracket. Set notation is going to be what you came up with, but make sure you put braces, x, such that. It's a sandwich, small, big, 1, 5. You have x in the middle, and you're going to have this situation with braces closed up. I think we got that one. Did we? Absolute value less than or equal to negative 4. It's going to be a sandwich problem. Oh, wait. What's wrong with this question? I have an absolute value, and I want to find out when it is less than or equal to negative 4. Is that even possible? I know absolute value is positive. The answer is no solution. Don't even get started with that problem. There's no need. How about greater than problems? Again, 2 parts. Positive, negative. And these are going to be the same. You have greater than 3, greater than 3. Work it out. I end up with x greater than 3. Divide both sides by -1. That's going to switch. Now look what I have. Let's look at number line notation here. Here's 0, -3 is 3. I want to be greater than 3, which is like that. Or I want to be less than -3, which is like that. So I put these two with an OR statement together. Okay. If I'm here, this works. If I'm here, this works as well. Great. How do I write that in interval notation? So I start with this piece. What's the smallest value? -infinity. Where does it stop? -3. Do I want -3? No. Parentheses. Now I'm going to talk about this one. 3. How far do I go? Infinity. Infinity always takes parentheses. Do I want 3? No. So it is parentheses. How do I put these two together? With the union. All right, great. Last notation. Set builder. How do I write that one? Braces x such that. Now I want x to be less than -3, and that comes from here. And from here I'm going to have this. How do I put these two together? Do I put union? Not in set notation. In set notation you put OR. Now be careful. Careful. Here we go. Some students will have the tendency of writing this like that. X. Let's see, how do you guys do that? Something like that. That's not going to work. Okay? That's not an allowed notation. Remember, that was in the first video. Or any version of that. I don't know. Something like that. None of that will work. You're going to have an OR statement with the greater inequality. Okay. All right. So let's do this problem. 2x minus 6 greater than 2. Two parts. Plus 2x minus 6 minus. This part doesn't change. Greater than. Greater than. Let's work it out. Add 6 on both sides. Give 2x greater than 8. Divide both sides by 2. X greater than 4. Let's work this one out. Negative 2x plus 6 greater than 2. Subtract 6. Negative 2x greater than negative 4. Divide by negative 2. X is, this is going to flip, less than 2. X is less than 2, greater than 4. Well, how do I show that in number line notation? 2, 4. Greater than 4, this way. Less than 2, that way. Interval notation. I have to start from -infinity to 2. Union. 4 to infinity. Set builder notation. Braces x such that x is less than 2. How do I put this in there? Or x is greater than 4. All three notations. Okay, how about with the equal thing? Okay, two parts. Let me change my marker. Positive, negative. This part stays the same. Okay, let's work it out. -8, -8. Negative 2x greater than or equal to -6. Divide both sides by -2. X is, this is going to flip 3. Okay? How about here? Work the negative in. Add a. 2x greater than or equal to 10. X greater than or equal to 5. How's that work? Number line. 0, 3, 5. Less than or equal to 3. Greater than or equal to 5. Number line. How about set? This way, negative infinity to 3. I want 3. 5 to infinity, I want 5, but I don't want infinity because infinity never takes a bracket. How do I put 2 together with the union? Set builder. This one is not set. This one is interval. And this one is the set builder. X such that x is less than or equal to 3. I can just take it right out of there. X is greater than or equal to 5. Take it right out of there, braces. How do I put these two pieces together? With an OR statement. Very good. Here's a tricky one. 8 minus 2x greater than negative 2. I can split it into pieces. Oh, wait. Let's think. I have a negative on one side. That should just raise a flag right there. When is an absolute value positive? Always. Good. So, if you have a positive number or 0, is it always bigger than negative 2? Yes. I don't have to do all this work. All real numbers. You're going to remember that, right? Great. How about putting the both together? If I had this, never. I have this, always. All real numbers. How about this? Never. Don't mix those three up, and you'll be okay.